So given this model up here for circular motion of an object, the question asks you, what is the kinetic energy of a rigid body in terms of I, the moment of inertia? It also gives these three equations here, where K is the kinetic energy, I is the inertia, and V is the velocity. So what do you think the answer will be? Comment down below. The answer is actually B, but why? So if we use the relationships given, we know that the kinetic energy is equal to 1/2 mv squared in general, where m is mass and v is the linear velocity. We also know for a rigid body, I is equal to mr squared, where m is mass and r is the radius. But how do we relate I, the inertia, to K, the kinetic energy? We need a relationship that bridges angular and linear motion, which is V equals omega r, where V is the linear speed, omega is the angular velocity, and r is the radius. So if we take a kinetic energy equation, we can plug in V equal to omega r, we get this. And if we square this term, we end up with this expression here. So this is the kinetic energy for angular motion. We know that I is equal to mr squared, so we can notice that this term here is actually equal to I, so we can plug that in. And so we arrive at our final expression here, which if we look above is equal to this. So that's how we get the answer.